So let's continue with our calculation of the vector potential A for a current carrying loop, and from the vector potential, the calculation of the magnetic field. Okay, so this is our expression for A. We're going to have to be careful with our expressions for R and R prime in this particular calculation. You'll remember I argued that we need to know the vector potential in a small region around our point of observation because we're going to take the curl of A. So I've stepped off axis here, and my point of observation R is in fact going to be the following vector. Furthermore, I'm going to have to be a little bit careful about this rho hat piece, which is telling me about my point of observation, and the rho hat down here. I've written this as rho hat prime, and this is rho hat. I have to distinguish between this vector and this vector because, in general, they will be in different directions. If you think about looking down on on our picture, in fact, we could see that very clearly. Imagine we're looking down the z-axis, we're looking down here onto the xy plane, and we're going to see this vector, and we're going to see this vector. In general, they will be in different directions. They might look something like this. Okay, so this is what we might see. Now clearly the angle between rho hat prime and rho hat, the angle between these is the difference of phi prime, this angle, minus phi. So phi prime minus phi would in fact be that angle there. Alright, so that angle that I've marked in red would be our angle phi prime minus phi. And that is the angle between the rho hat and the rho hat prime vector. So this is something that we are going to have to include carefully in our calculation, or we will get things wrong. So let's set up our shopping list of items which appears under this integrand. Okay, so I've written out our expression for R, I've written out our expression for R prime. I would like 1 on mod R minus R prime. So I've written this as R minus R prime to the minus 1. If I want to take the mod square of a vector, I dot it into itself. This would be the mod square. I then have to take the square root of that vector and the reciprocal of the square root. So I've got a factor of a minus a half here. When I do the dot products, all the terms z hat dot z hat is 1, and so on. Rho hat is 1, rho hat prime dot rho hat prime is 1, and all the cross terms are 0 aside from terms like rho hat dot rho hat prime. So I get a z squared, an r squared, a rho squared, and then I get this factor here, this rho hat dot rho hat prime term, and we're going to have to deal with that. Before we deal with that, let's deal with the rho squared term. Remember, I want the A field, the vector field, in an infinitesimally small region around our point of observation. So I'm going to do everything in the limit that rho squared is small compared to z squared plus r squared. You'll notice this is a quadratic term in rho squared, this is a linear term in rho. This is a quadratic term in rho, this is a linear term in rho, and we're going to throw this term out. Let's do that formally on the following page. Okay, so I've factored out this term here, z squared plus r squared, linear term in row divided by this. You'll notice these are now all dimensionless quantities. A quadratic term, this one I'm going to remove because I'm only interested in infinitesimal displacements around my point of observation. The only thing I've left to deal with now is that term rho hat dot rho hat prime. But that is just, since rho hat and rho hat prime are both unit vectors, it's the cosine of the angle between them. And that term, of course, is just the following. Okay, so now I can substitute this expression up into here, and I can do the expansion. So let's do that. We've done expansions like this before. Okay, so here then is our expression for the quantity that appears downstairs in the integrand. It's approximate because we're interested in infinitesimal rho. We now have the angles phi and phi prime, and we're pretty much ready to calculate. So the calculation of A we will continue in the next segment.